Welcome everybody. Today we're going to be continuing our discussion of vectors and making our own. Your first group project is going to be implementing vectors. And last time we implemented some of it, not all of it. I'm going to go ahead and pull some of these functions out and let you guys write them today. So we have a constructor, destructor, we have a copy constructor that is currently broken. Yeah, okay. So here we go. Okay, so we've got code here that can push back. We can do bob.at, 3 equals -70. And then we need to fix our copy constructor and our assignment operator. So what we could do is we could just say for int I equals 0, I is less than capacity, I++, I think is what we had last time. Our array square bracket I equals other square bracket I. And other dot R square bracket I. Close the door, please. Close it.
I have cat hands.
There. Okay. And we'll do the same for the assignment operator. Because again, what we're doing here is instead of just copying the pointer, what we're doing is we're giving the new vector its own array and then copying over all the elements from the other guy. And we should also probably copy the size as well. So we should say our size is equal to the other guy's size. And now we've got a working copy constructor and a working assignment operator. So if we said Sydney equals Bob here, that's going to call the copy constructor. If we say Sydney equals Bob here, this is going to call the assignment operator. Every time you do anything that's like plus or minus or equals, it's actually calling a function under the hood. And we're gonna be doing more with operators next week. But for now, all you need to know is that there's something called the assignment operator that is an equal sign. And so when you say Sydney equals Bob, it calls this function, unless you're making a new variable. Whenever you make a new variable, it calls a constructor instead. That's the rule. They look very similar. And a lot of people get the copy constructor and the assignment operator confused, but they're actually two different functions. And you need to write both of them. And they're probably even going to be a little bit different, even though they're mostly the same. Okay, so any questions about that? Okay, neat. So, okay, so let's have some volunteers. Altamarino, thanks for volunteering. You here? Go ahead and say something, Lily. Silence. Goosey, you here? Gonna toss them into the AFK channel, see if they notice. See if they come back. Stevie, you here? Yeah, okay, all right. Goosey made it back, I think. Yeah. All right. Goosey came back, but he does not want to volunteer. All right. Goosey, are you here? You're on your phone right now. Fair enough. Lily's here. Excellent, excellent, excellent. So thanks. We have 3 volunteers. So, our pushback function is going to copy an element into the end of the array and make the end of the used part of the array, and then increase our count. Size is how many elements are currently in the vector. How, Lily, should we write a pop back function? So a pop back function should delete the last element of the vector. So let's think about this. What return type should it have? A pop back function that deletes the last element of a vector. How should we go about writing this function? Start off with a return type. What return type should it have? Anybody? Chime in. What should it return? The array index? No. The integer, the value of the thing popped off? Yeah, you can do that if you want. I'd also accept void. Okay, so how do we get the last element in the in our vector? Remember the picture of a vector? Here's a picture of a vector. Got front. After we pop back, I guess. I don't really understand this. After we pop back, the 2 is going to be deleted, and 8 is going to be the new back, the new end of the vector. So Olson wants to return the 2. Okay, so if we before we call pop back, our size is 5. We have 5 elements in the vector. So what should we do? What should this code do? We don't have a back, do we? We don't have a back. Okay. So how do we get the last element out of the vector? How do we do this? It's gonna be some element of the array here. If you remember, we've got size is how many elements are currently in our vector. So 9 is not correct because we might only have 5 currently. This is the maximum. Capacity is the maximum amount of people that we could have in our vector. What you guys are going to be writing on Friday is a vector that when it fills up, when the size hits capacity, and you try push backing one more time, it'll allocate a new array that's twice as big. You're going to copy all the values over, and then deallocate the old array and have the R pointer point at the new guy. That's what you're going to have a week to do. All right. There is no dot back. There is no dot back. Can't use that. So what should this be? Here's maybe a better one. End. We don't have an end either. You guys are calling functions that don't exist. So if our size right now is 6, the last element is in 5. Okay? So if our size is currently 6, we have 6 elements in the array. The very last element is in index 5. So it should be size minus 1. It's a very common pattern that you guys will see a lot of. Okay? So that is what the value is we're going to return. Now, how do we delete it out of our vector? So we've got a allocated array. This one has 11, I guess, in it, but we've got an array that's allocated 11 here, 10 in our code, squares, integers of memory. How do we delete the last element out of the vector? Any ideas? How do we get rid of, we call pop back. We need to get rid of 7. How do we do that? Yeah, you don't have to do anything to that value, actually. All we need to do is say size minus minus. That's it. That's the only thing we have to do. That's it. That's delete. Just reduce the size by 1. Okay. So we need some error checking on this. Sartorelli, what is a possible error condition that could happen here? What bad thing? The delete command would not work. The delete command would unallocate the entire array, which we don't want. If we have a block of 10 integers, you can't delete just one of them. And in fact, when you look at how it works in the standard library, they typically will, if you pop back a bunch of times, they just leave whatever was allocated there before. Typically, the capacity usually stays the same. You just pop off down to 0, and you still have memory allocated. They typically don't deallocate it. You can, I guess. Really don't. So what error condition do we need to check for? Come on, you guys are being really quiet today. Lamar Medina, what is a possible bad situation to call pop back in? That wouldn't make any sense. Size of the array is 0. Good. So if the size of the array is 0, which we could write like this if we want to be a little bit more compact. If the size of the array is 0, we can throw an error, throw a runtime error, popping off of an empty vector. What do you think the standard library does? What do you think the standard library does if you call pop back on an empty vector? Nothing? Let's find out. So if we have a vector of integers named vec, size 0, and we call vector.popback to delete the last element of a vector that's empty, there's nothing there to delete. Let's find out what happens, okay? And we'll just quit after that. Okay. So the backslash, by the way, means I'm not compiling it with any of my cool aliases, things like that. No safe standard library, no optimizer, none of that. Okay. What happens? Absolutely nothing. What if we compile this with the safe standard library? Easy peasy, by the way, detects this. Hey, you're deleting from an empty thing. And if you have the safe standard library, then it will say, hey, I'm attempting to access an element in an empty container. Don't do that. And the safe standard library will actually quit your program, and then that's good. It's actually good that it kills your program because you screwed up pretty badly here. And by default, C++ does not do very much error checking for you. So if you want to know where your code is crashing, by the way, there is a program called GDB by our Lord and Savior Richard Stallman. The GNU debugger was written by Richard Stallman in part. And GDB a.out will run your program inside of the GNU debugger. You load it up like that, you hit run, and it'll tell you, oh, your code died on nptl pthreadkill.c line 44. Not helpful. What the heck? I didn't write a program called pthreadkill. That doesn't make very much sense to me at all. And so there is a command inside of the GNU debugger called backtrace, or BT for short. Okay. If you type BT, you can see that your code was on line 74, bless you, of main.cc. And you called pop back, and then that raised the signal that killed your program. So that's the culprit right there, line 74 of main.cc. So if you vim main.cc, line 74, then you'll see the line that killed your program. Very useful stuff. You guys should get comfortable with GDB. By default, though, doesn't do anything. So what would happen? What do you guys think would happen if I output the size of the standard library vector? No safe standard library, no safety at all. This is just plain G++, main.cc, nothing else. What do you think this is going to print if I ask it for the size of a vector after I just popped off of an empty vector? Any guesses? The actual size? I don't know what the actual size is. We had size 0. There's no elements in this, right? I didn't create it with anything. And then I deleted the last element from something that it has no elements. So how many elements are there now? I don't know. What is the actual size? I don't know. We're in undefined behavior territory right now. -1. Yeah, there is no -1 possible because the size of a vector is an unsigned 64-bit integer. 0 would make sense, but it's not. Instead, this is the size of the vector now. So this is why, boys and girls, we put error checking into our code. but it's not my responsibility. Yeah, I don't care. I don't write code that can crash, right? I don't write code that can get into an erroneous state like this. We live in a science fiction future where, you know, CPUs run, you know, billions and billions of times a second. We can put an if statement in to check to see if you're popping off an empty vector. Okay.
Dad, what was the cruise that we went on
To Alaska? I don't know. I don't remember.
Was it like, wasn't it like Oasis of the Seas?
Yeah, it makes sense. So Princess? No.
It was Oasis of the Seas.
Was it? No. Okay. Yeah. So by default, the standard library does 0 error checking. But the way that I've got your guys' code configured, it will. Okay. So our code. So we got Bob here. Push back a lot of things. Pop back. That'll delete the 19, all right? So we just added 10, 11, 12, 13, 14, 15, 16, 19. And then with a pop back, that's going to delete the 19. And then we're going to copy it into Sydney. Wouldn't it be cool if we could do something like this, like use a range-based for loop for every integer in Sydney, you know, see out that integer? That'd be cool, wouldn't it? That'd be neat. Yeah? What do you guys think? Our code doesn't work, though. This doesn't work. The reason why it doesn't work is because a range-based for loop uses a pair of iterators. So this is kind of our topic for this week, right? It's basically equivalent to saying for auto iterator equals Sydney.begin, as long as iterator is not equal to Sydney.end, iterator plus plus. So this is what you get whenever you do this with a range-based for loop. It calls begin and end on whatever data structure you put into the right-hand side there. So why isn't this code compiling? What functions are we missing that we could add to our class that would allow us to use a range-based for loop? What do you guys think? I need to open the window. It is hot in here. We don't have a way to iterate through it. Yeah, it's true, but what functions do we need? There's 2 functions that we need to get this to work. That is correct. We need both begin and end as member functions of our class to get this to work. Okay, so let me show you how easy this is. We're going to make a function called begin, const, because it's not changing our class, and it is going to return r. That's it. A pointer is actually considered an iterator. So if you have a pointer, that works anywhere an iterator is expected. And an array, which is what we have under the hood, is a pointer, and a pointer can be returned as the beginning of the array. The beginning of the array is just the array. So it's actually very easy to write. And then the end is 1 past the ending. So what should I put here? Return r plus what? And this is, remember, if you say r plus 1, that points to array square bracket 1. R plus 2 points to r square bracket 2. We need to point at 1 past the end of the chunk of memory that we're using. Plus 1. We say plus 1, then it'll only, the end will, it'll only ever print one thing with a range-based for loop. Yeah, it needs to be array plus size. Okay. And so if we have 5 elements in our vector, then it'll be array plus 5, and it'll print out the first 5 elements of our thing, and that's all it takes. And now we have a range-based for loop that'll work. Simple as that. Nope, not GB. And there we go. So you can see that we had the numbers from 10 to 19. 19 got popped off, and 13 got changed to be negative 70. Everything's working. Isn't that neat? That's how easy it is. You can oftentimes do something just as simple as that when you have something just like an array or something like that. For more complicated classes, like linked lists and binary trees, the iterator classes get a little bit more complicated. Okay, so we've got a dot begin now. We've got a dot end. Those are looking pretty good. We got pop back. Pop back is going to throw a runtime error if we pop off an empty vector 10. So if I call bob.pop back here, verify. This should kill our code. I don't see Louis out there now. And so this says error popping off of an empty vector.
Louis.
You guys understand? This will kill.
Oh my! That Louis out there. Hi. Hi.
Yeah, we got a cat outside of our window now.
Should we show them?
Yeah, that's all right. Okay, there's a cat outside.
He's on our porch. You're so
All right, what other things we need to add to this class? We got our copy constructor. We got our assignment operator. We got our destructor. We got our constructor. Pushback, popback. What about size? Do we have size? Get size. Should this function be const? What do you guys think? A const function does not modify the variable that it's on. Should we be changing our vector if we get the size of the vector? What do you guys think? Should it be const? Every time you make a member function, you should be asking yourself that. Const means it's not modifying the object that it's on. It probably should not be changing the vector. That is correct. So this should be const. And then what should we write for get size? How do we return the size of kitty?
Behold the cat that is outside of our window.
All right, cat. How do we return the size of our vector? What do we type to return the size of our vector? Return size is correct. Very good. Olson, again, being the only person answering half the time. All right. So, that looks pretty good.
Yeah.
There's usually an is empty function. Is empty will return true or false if the vector is empty. In the standard library, by the way, is empty is just called empty, which is very famously one of the worst named member functions in a vector, because if you call vec.empty, you're expecting to empty the vector, that you're going to clear it. And instead, empty returns true or false. So what should the return type be? Everybody, not just Olson. Olson, don't answer the next couple of questions. I want everybody answering this, because they're just letting you carry the class. What should the return type be? It's going to return true or false. Bool is correct. Should it be const? What do you guys think? Should it be const? Ask yourself if it's empty should change the vector. Yeah, it should be const. Very good. All right, next. How do we write code to see if it is empty or not? Actually, we're going to do it is empty. Honestly, that's what it should have been named in the standard library, is empty, because is empty sounds like a Boolean. Empty sounds like a verb, right? So I don't think it's very well named. So how do we tell if our vector is empty, if there's nothing in it currently? If size double equals 0, return true. Great. If size double equals 0, return true. Otherwise, return false. Do you guys like that? Is it correct? What do you think? If size is 0, return true. Otherwise, return false. What do you guys think? Does it look good? Olson, give us a way to do this again with less typing. This is correct. Olson, give us a way that we'll do this with less typing. The less typing version. Size is empty. What else? Clear, maybe. Think. How can we do this with less typing? Ooh, a ternary operator. That's good. That's good. I like that. How about... Okay. So if size is 0, not 0 is true, so it returns true. It is empty. For any other value, not 7, not 12, whatever, it's false. Not 7 is false. There you go. Easy. All right. And then for clear, this is going to throw away everything in the vector. So how do we do this? What is the easiest way of deleting all of the integers that we have allocated? Our size might be 3 currently. We might currently have 3 integers in our vector that has a maximum capacity of 10. How do we throw all 3 of them away? One line of code. Don't need a for loop. We could do a while loop where we say while not is empty, pop back, something like that. That would be an order n solution. Do we just set size to 0? Yeah, well done. Round of applause for Medina, everyone. Size equals 0 indeed. That's it. We're done. I don't even have to go through there and erase anything in there because we can't access them anymore. If you ever try accessing something out of bounds, right, then it'll say, no, you're out of bounds, and disallow it. We don't actually have to bother going through there and zeroing out data. It's a waste of time. That would make it an order n solution when we have here an order 1 solution. Okay. Does you understand? Constant running time. Constant running time, order 1. Because it doesn't matter if the vector is size 100, a million, a billion, a trillion. When we call clear, when we delete all of the billion elements in the vector, it just sets size to 0 and we're done. Now, the standard library actually does this in order n time. And the reason why it does it in order n time is because it calls the destructor on every element in the vector. But we just have integers, and integers do not have a destructor. So easy, one line, done. Okay, so this is looking pretty good. This is like a pretty good approximation of what you guys are gonna have to do for your lab. So the main thing you're gonna have to do is in the pushback function, if size ever exceeds capacity, instead of dying, you are going to allocate a new array that's twice the size of the old one, twice the capacity of the old one. You're going to copy all of the elements from the old one to the new one, delete square bracket r, delete the old one, and then set r equal to the new one, and you're good. It's just a for loop. You're going to have 9 days to do it. So not too bad. This is going to be your first group project. So you are going to be put into groups of 4 right now. So everybody who wants a group, please, in other words, everybody who's here, because everybody wants a group, you have to have a group. This is just a check again to see who is AFK. Everybody who is currently live with us, put onto the chat channel, I'm here, and then you will be grouped up. For people who are watching this at home, put a message out onto the CSI 1 channel after hours, and then we will find you a group that way. So I'm going to stop this recording here, and Mincarelli is going to come on and explain our first very exciting group project for you guys. We're going to use a little ChatGPT, a little standard library, some benchmarking, some report writing. It's going to be pretty exciting. We're pretty pumped up and excited for this. So I'm going to, again, stop the recording here and start a new one with Mincarelli explaining the project to you guys.
Yeah.